Alright, this is number 29 from the study guide, chapter 4 study guide, and it's a proof. So let's see what we can do. Let's change this to red. We can mark this up a little bit. Let's mark this stuff. AB and DC. Here's AB and DC. It says that they're parallel to each other, so I put arrows on here just to represent being parallel. And it also says they're equal to each other, doesn't it? So I'm going to put a little tick mark right here, a little tick mark right here. And we're trying to prove that triangle ABE, where's ABE? This one right here. Do you see it kind of sitting on its side or whatever you want to think of it? That one right there, ABE, and CDE, this one right here, we want to prove that they're congruent to each other. We good so far? Alright, so let's think. What did I say when I first drew this thing, the parallel lines? First thing that pops in my mind is alternate interior angles and transversals, right? So let's see. Parallel lines. Do I have a transversal? Nico, you said transversals. What's a transversal here with AB and DC? AC, good. That's a transversal right there. So I've got two parallel lines cut by a transversal. Do you see something now? Do you see this angle? What's that angle going to equal?
C.
Yeah, we can't just say C, though, because I don't know what C means. That could be C, that could be C, the whole thing could be C. ECB, is that what you said? ECD, good. Okay, so look, they're alternate interior angles, aren't they? Okay, so they're going to be equal to each other. That might help us out a little bit. Do you think? Did you think of that when you saw parallel lines? All right, we've used that a few times. Now you should think about it, okay? So if I see parallel lines, automatically I'm thinking, hey, wait a minute, I could probably go alternate interior angles somewhere. So that's the first thing I looked for. So I specifically looked to see if I could go alternate interior angles. And sure enough, that's my transversal. Do you see it? This connects the parallel line to the transversal. This one connects the parallel line to the transversal. We good? All right. Do you see that happening anywhere else? BD is a transversal, isn't it, between those two parallel lines? So angle D would equal what?
ABE.
ABE, this one right here. Good. So they're equal to each other. What's my reason? Alternate interior angles are equal. That's correct. Okay. Do I need to go vertical angles at this point, though? I could. You wouldn't be wrong. But do I need to? No, because I already got it. Do you see it? What do I mean by I already got it? Angle, side, angle. That's right, because look at this triangle. I've got an angle, I've got a side, got an angle. The side's included, isn't it? All right, so it's not angle, angle, side, is it? It's angle, side, angle. And look over here. I've got the same angle, the same side, the same angle. So these two triangles are congruent because of angle, side, angle. Travis?
Can you get only one two alternate interior angles, and then you have one side, then you have the angle AEB and angle.
Yeah, you could have done this if you didn't want to go. Yeah, if you didn't want to go both alternate interior angles, you could have said this. All right, if you didn't want to say that this angle was equal to this one right here, you could have said that these vertical angles are equal to each other, and then gone angle, angle, side. That would have been fine. You could have done that. But I was kind of on a roll already with that alternate interior angles. Do you see that? So I'm like, oh, I got alternate interior angles here. I got alternate interior right here. We might as well just use those. It's all in the same step, isn't it? So that kind of saves me from doing another step. But you're absolutely right. You could have said that this was equal to this and then gone angle, angle, side. Right? You'd still have to do alternate interior angles one way or the other. Right? Okay. Let's just write this down real quick just so you have an idea of what we should be writing. All right? This is statements. Alright, and reasons. This is what I want to see on your proof. I want to see a two-column proof. I want to see statements. I want to see reasons. Now, the picture's already drawn for you on the test. You don't have to bother redrawing the picture, okay, or even restating all this stuff. Okay, but this is what I want to see. You follow me? Now, what I would do on your test, this is on the front of the test, I would mark the stuff up right on the test itself. But this has to be on the answer sheet. You got it? Because I'm only looking at the answer sheet for answers. But you can mark up the test. I don't care what you write on the test. As long as on the answer sheet you have your answers. So what's the first thing that we said? We want to go angle, side, angle in that order, correct? So let's do the parallel lines first, and then let's go this angle. So the parallel lines. So AB is parallel to DC. And what's my reason for that? It's given. Okay. Now, why did I care about that? Let's not go straight to the next given. You follow me? Let's not go to this. You could if you wanted to. It wouldn't be wrong if you put both givens up top. But look, I want to go angle, then I want to go side, and then I want to go angle. You get it? Because it stays in a nice order. I think it's a little more logical that way. So, got the parallel lines. Now I can say that this angle A is equal to this down here, which is what? DCE. So let's write that. So angle A. Can I just call this angle A? Do I have to use 3 points for this? No, I don't have to, because this is the only angle coming out of that vertex, isn't it? All right, so I can just say angle A equals angle. Now I can't just call this C. What do I have to call it? DCE, or I could call it DCA, or let's just go DCE. Is that all right? DCE. Now, why are they equal to each other? Good. Alternate interior angles are what? Are equal or congruent, right? Don't just say alternate interior angles. Say that they're equal to each other in your reason. All right, so what did I just do right there? I just found what? An angle, didn't I? Let's go to the side now. All right, so what would the next step be? Yeah, it's given. AB equals DC, or congruent to. And why is that? It's given. Yeah, could I have put that up here in the first step? Sure, I could have, but I kind of like putting it in order, don't you? So I've got my angle, I've got my side. So there you go. I've got this, I've got this. Now I got to say this one right here. Well, I kind of had that step already up here, didn't I? But let's just put it down here so it all works out real nice. So what am I going to call this angle right here? ABE, all right. So angle ABE is congruent to, and yeah, I could just call this angle D, couldn't I? So call it angle D. What did I just do right there? That was my what? That's my other angle. So there's an angle, there's a side, there's another angle. What's my reason for that? Alternate interior angles are equal. Alternate interior angles are equal, or congruent, however you want to say it. Now look what I have. See why I like putting it in this order? Because now I look at it, I'm like, oh yeah, I got what? Angle, side, angle. So what must be true about these two triangles? They got to be congruent. So it's triangle ABE. Now let's make sure we put it in the correct order. So if I go ABE, I'm going from one arc to two to none. So what do I have to do over here? CDE. And that's exactly how they wrote it up there anyway. So CDE. And what's my reason? Is it CPCTC? No, that doesn't make any difference. It doesn't make any sense, does it? It's, how do we prove triangles congruent? In this case, angle, side, angle. You got it? That's it. That was pretty simple, wasn't it? And that's the style of proof that you're going to have on the test. All right, it's not going to be much longer than this at all. It'll probably be about the same number of steps, same kind of thing. I'm not promising you that you'll have parallel lines. You could have like midpoint, right? If it hits at a midpoint, you know the two segments are equal for what reason? Definition of midpoint, exactly. What if it says a ray or a line bisects an angle? What would you use to say those two angles are equal to each other? Definition of angle bisector. You with me? Okay, so think of those. Think of the definition things. What if I wanted to prove that ABC, you see it? See this big old right? It kind of looks like a right triangle. I can't say it's right, but ABC and DCB are equal. What would be a key step that they didn't tell you in the given? Probably BC equals BC. Do you see that? What's my reason for that? Reflexive. If something equals itself, it's reflexive property. Make sense? All right. Again, I'm just looking at it and thinking, oh, that could be reflexive, right? But that's not going to help you with the two triangles we're trying to prove, is it? I'm just thinking outside the box and saying, okay, what if they wanted to prove ABC and DCB? Oh, yeah, BC and BC are reflexive, aren't they? So, I don't know. Who knows? That could help you a little bit. Make sense? All right. Does that help just a little bit? Is it getting a little bit better now? Those proofs aren't so bad, are they? It's pretty easy. All right, let's try another one. All right, here's our next proof. Let's see what they tell us. And let's go to red so it stands out a little bit. It says WY. Where's WY? That's this vertical one right here, this up and down one. It bisects angle XWZ. XWZ. Oh, this big angle up here. So that thing down in the middle bisects this whole thing right here, which means what? Which means that this angle and this angle right here are going to be what? They're going to be congruent. They're going to be equal to each other. Okay? Why? What's my reason? Definition of angle bisector. Exactly right. And it also bisects XYZ. XYZ is this bottom one down here, so that means that this one, notice I put two arcs on this, right? That doesn't mean that this angle up here equals this angle up here, or down here up here. You get it? Okay. So, but they do equal each other. All right? That's all they tell you. And you have to prove that the triangle's congruent. Which triangles are we trying to prove? WXY. WXY. So it's this long skinny one here on the left. Chandler, what do you see?
Doesn't angle WXZ have to be congruent with WZX because
WZX. You're saying this one and this one?
yeah,
Okay.
because they have to equal, like in the triangle those two angles have to be the same, like because it's
You're saying this whole big angle, or just this one little one
that
right here? This one right here?
there.
No. And that's not really going to help you knowing other angles are equal to each other, to tell you the truth. Because do we have an angle? Do we really want to show all three angles? We don't really care about that because we don't have an angle theorem. Travis, what do you see?
WY just reflects it.
That's good. WY equals WY. Do you see it? What am I trying to do? I'm trying to prove that this triangle over here on the left-hand side is congruent to this triangle over here on the right-hand side. I've already got two angles, don't I? I've got an angle and I've got an angle. What else do I have? Yeah, we'll just kind of put a... Do you see that? So I've got an angle. I've got this whole entire side right here. That's where that little tick mark is. And then I've got this angle. So why are the triangles congruent? Angle, side, angle. So really, I only needed one extra step in there, didn't I? I got my givens, right? Well, I actually do have to put a couple steps. So let's go through it. I don't think I have enough time to write it down. We'll just talk through it. Is that all right? First thing I'm going to say is the given, that it bisects it. If it bisects it, then what's true about this angle? This angle is equal to this angle. My reason? We said it 2 times already. Definition of angle bisector. All right. Then if you wanted to, you could go straight to this side right here, couldn't you? So this is my angle, right? So I've got an angle, right? Because definition of bisector. And then I can say WY equals WY. That's my what? That's my side reflexive property, correct? And now I can go down to this angle again. Why are these two angles equal? Definition of angle bisector. That's my other angle. Why are these triangles congruent to each other? Angle, side, angle. You get it? Now they could ask you this. What if? What if they ask you to prove that, let's see, XY, line segment XY equals line segment ZY? That's right. You'd go through the thing. You would say angle, side, angle for the triangles, and then you could say XY equals ZY because of CPCTC. Make sense? All right, it's just one little extra step, isn't it? So prove your triangle's congruent first, then you can say the other stuff is equal to each other. Make sense? All right. That's not so hard, is it? I think these triangle proofs are some of the easier proofs that we're going to do. And hopefully you've kind of gotten the hang of it now. Yes? Who feels like, fairly confident? Fairly. Not 100%, but fairly confident. Okay, that's a good number of you. Good. All right. I think that's it. Unless there's anything else that we didn't cover that you really weren't sure about. Minutes. All right, it does have tick marks on all 3 sides, and it says that this is 3x plus 6, and this is 4x, and this is 5x minus 6. Now look, all 3 sides are equal to each other, aren't they? So if I want to solve for x, I could set any pair of these sides equal to each other. It doesn't matter because they're all 3 the same. Let's just do the 4x equals, I'll do the easiest ones, I think. 4x, this is number 15. Okay, so let's set 4x equal to what? You can set it equal to either one of these. It doesn't make any difference. Let's just set it equal to this. Makes it easy, doesn't it? Subtract a 3x from both sides. I get an x equals what? 6. So that's what x is equal to. But now you got to find the other sides there, don't you? Don't forget. Make sure you read the instructions. All right, so this is what? You can do this in your head. 3 times 6 is what? 18 plus 6 is 24. Now, you know they're all the same, don't you? So if you wanted to, you could just say 24. But just for fun, let's throw it in and make sure it is. 4 times x, 4 times 6 is what? 24. Okay, 5 times 6 is 30. Minus 6 is 24. How about that? So they're all 24. We got it? All right. Anything else real quick?